Welcome to Chapter 5. Chapter 5 is all going to be about quadratic functions and different ways of solving quadratics and graphing quadratics. So we're going to start with the first section here. This is just about graphing quadratic functions. Give you a little bit of a review of some things from Algebra 1. I'm pretty sure most of you handled quadratics in Algebra 1. But as usual, we're going to start with the basics, the things you already know, and then extend on that and build upon it in Algebra 2. All right, so let's talk a little bit about these quadratic graphs. Now notice for the first time, we're using a curved graph this year. We're not using a straight line anymore. Okay, these graphs have a name. They're called parabolas. You might want to jot that down. Okay, again, you should have seen that word before. Now every parabola has some properties in common. These two parabolas that are on my slide are also on your notes. All right, so you may want to take note of some of these different things I'm going to draw on this graph. First off, you're going to notice that every parabola has a line of vertical symmetry. Okay, this dotted line that I just drew is called the axis of symmetry. Come on, let me write it down. The axis of symmetry. Okay, if I folded this blue curve along that red dotted line, notice that it would overlap. It would touch the one side to the other. Okay, that's going to happen for both parabolas that point up like this blue one and then also like the red ones. That's another thing that's a little bit different about parabolas. Some are going to point up, some are going to point down. We're going to talk more about how you can determine that this chapter. But regardless of the direction that they open, they're going to have an axis of symmetry. Okay? The point where that axis of symmetry intersects the parabola has a name, and notice again, whether it points up or down, it is going to have that point. That name is called the vertex. Okay? We looked a little bit at vertices when we were talking about absolute value functions. So that's not a totally new word for you this year. Okay? Something else that's interesting to note about these graphs, the vertex is either the minimum value of the function or the maximum value of the function, depending on whether the graph opens up or down. Okay? And then again, most parabolas will have somewhere a y-intercept. Okay? And there's the y-intercept of the red one, and there's the y-intercept of the blue one. And occasionally, more often than not, but not always, there will be two x-intercepts. More on the x-intercepts later in this chapter. They are actually very crucial points to this graph, but we're going to label it right now so that we have it. Okay? So these are all the big properties of any parabola. Your axis of symmetry, your vertex, and then your two different intercepts. All right, so let's talk about how if we're given an equation of a parabola or an equation of a quadratic function, we can come up with what its graph should look like. And I have some steps for you to fill in with your notes. Feel free to pause this, rewind this as needed for you to get this copied down accurately into your notes. All right, so for starters, we're going to determine the axis of symmetry. Oh, by the way, you should also note that the standard form for a quadratic function, okay, this is not in your notes, this is not on the slide, I'm adding it because it's going to come in handy here, is f of x equals ax squared plus, that should be a plus sign, bx plus c. The a, b, and c are going to be very important as we go through these steps. All right, so we're going to determine the axis of symmetry. The axis of symmetry will be at the point, or on the line rather, x equals negative b over 2a. Okay, so we'll plug in our b, we'll plug in our a, and we'll get our axis of symmetry that way. The next thing we're going to do is figure out where the vertex is. And the x-coordinate of the vertex, good news for you, since the vertex intersects at the axis of symmetry, it's going to have the same value for its x-coordinate, negative b over 2a. So once you do that arithmetic, you actually get a 2-for-1 here. Not only do you get the equation of your symmetry line, you also get the x-coordinate of your vertex. Now, the y-coordinate is going to just be the value of the function at negative b over 2a. So in other words, we're going to just plug in whatever that number is for x to get our y. Okay? The next thing we have to do, my slide will advance, is figure out where the y-intercept will be. And that will always be Well, the x-coordinate has to be 0 for it to be a y-intercept. Think about if I made x 0 up in this general form. What would be left over? I bet you could probably guess what the y-intercept would have to be. If you can't guess it, I'll give it to you. It's going to be at c. So 0, c will always be the y-intercept of any quadratic function. Okay? Once we get these three things, we plot them all on our grid. Okay, we plot our line of symmetry up here. We plot the point that's the vertex. It'll be somewhere along this axis of symmetry, always by definition. And then we'll plot our y-intercept. Okay, so we have 2 points. If this were a line, that would be good enough. But we need one more point. And the way we get that third point is we use the symmetry of the parabola. And we find a third point that's directly across from our y-intercept using the symmetry that we have of the graph. And you'll understand what that means when we do a couple examples if you haven't seen this before. And then finally, those 3 points just get connected with a curve and you have your quadratic. All right, so at this point, I'm going to do a couple examples for you, and then that'll be the end of the video, and you'll get a chance to try a few more, and then we'll do more of this in class. We'll work in the graphing calculators as well, and talk a little bit about some extensions of what we can get from our graph. All right, so here's a first example. I want to sketch the graph of f of x equals x squared minus 2x minus 3. Now again, this is in standard form, so we have an a, we have a b, and we have a c. Okay. The first thing we want to do is we want to get our axis of symmetry. And we said that that's going to be at the line x equals negative b over 2a. Okay, so I go up to my equation. B is negative 2. So negative 2 will be negative b. And then there's no number in front of the x squared, so a's got to be 1. So 2 times 1. So negative 2 is positive 2. 2 times 1 is positive 2. I can reduce that to lowest terms. My axis of symmetry is going to be at x equals 1. Now I'll get my vertex. Okay, it's going to be a point. The point has 2 coordinates. The x-coordinate is going to be 1 because it's negative b over 2a. I can always just copy that number into my x-coordinate of my vertex. Now to get my y-coordinate, I have to plug in whatever this x number is into the equation and simplify. So f of 1 equals 1 squared minus 2 times 1 minus 3. We'll simplify that out. That's 1 minus 2 minus 3, and that's going to be negative 4. So at 1, negative 4, this graph has its vertex. The final point that we can get from the equation is the y-intercept, and that's going to be at 0, c, which in this case will be 0, negative 3. All right, so I have enough information, 1, 2, 3 pieces of information to help plot this picture. All right, so I'll go to my grid. I'll attempt to draw straight lines for my axes. As we all know, that's a little tough for me to do on this computer. All right, so we'll start with our axis of symmetry. X equals 1. So we'll go over here at 1, and I'm going to draw my dotted line for my axis of symmetry. Not too bad if I do say so myself. Okay. Now I'm going to go down to y equals negative 4, and I'm going to plot my vertex. So there's my vertex right there. Okay. I'm going to plot my y-intercept at 0, negative 3. And that's right there. Okay. Now I got to get a third point. So basically what I do is I put my pencil on the y-intercept. I count how many boxes it takes me to get to the axis of symmetry, and I go that many boxes on the other side. So from this point, I go 1 box to the axis of symmetry. If I go to the right 1 more, I'm now on the symmetric point opposite the y-intercept. You notice that those 2 points are equidistant from the axis of symmetry. And then from there, I can just connect these 3 points. That should be a smoother curve. If this was on a whiteboard or on graph paper, I would do a much better job of hitting these. And that's going to be my parabola. Okay? We're going to look at one more in this video. F of x equals negative 5x minus 10x plus 6. So again, we're in standard form, so we have an a, a b, and a c. We'll start with our axis of symmetry. The axis is negative b over 2a. This is a critical formula that you have to have memorized for graphing with quadratics. So b is negative 10, so negative 10 for negative b. A is negative 5, so we get 10 over negative 10. So the axis of symmetry is at x equals negative 1. Now I need to get my vertex. Okay, well the x-coordinate I've already got up here. X has got to be negative 1. To get y, I just make all my x's in my formula negative 1 and see what the math gets me. So negative 1 squared minus 10 times negative 1 plus 6. Negative 1 squared is 1 times negative 5 is negative 5. Negative 10 times 1, or negative 1 is positive 10 plus 6. It's going to add to 11. So negative 1, 11 is going to be my point of the vertex. Finally, we get our y-intercept, and that's going to be at 0, 6, because it's 0, c. And then there we go. All right, so now it is time to plot. And I got to go pretty high up on my y-axis. I'm going to put my axes a little bit different. I'm going to put them a little bit higher up because I have to go all the way up 11 boxes for that vertex. Okay. Y. And there's the x-axis. So at x equals negative 1, I've got my axis of symmetry. And there it is. Okay. And then I can plot my vertex. So at x equals negative 1, y equals 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 right here. I have my vertex. My y-intercept is at 0, 1, 2, 3, 4, 5, 6. Now I just need to get my third point, so I go on the y-intercept. I count however many boxes it takes me to travel from that point to the axis of symmetry. It's only 1, so I'll go over 1 more, and I'll plot my third point. I've got 1, 2, 3 points, which I can connect with a smooth curve. Again, the smooth here is pretty lousy for the way I'm doing this with my tablet. I get much better with this on the whiteboard, don't worry, ladies, but that is exactly the kind of thing we're looking for here, okay? So you have a couple more examples to try on the note sheet. Please do those. We'll go over a lot more of this in class. I know graphing is something that either you really like or you really don't, but we'll make sure we have it down for future classes and future lessons. Okay?